In this video, I will compare the directions and magnitudes of several different torques created by forces on a door. So in this one, 5 forces are applied to a door. For each one, to determine whether the torque about the hinge is here, whether it's positive, negative, or 0. So remember, the positive direction is counterclockwise, negative direction is clockwise. So what we have to do is for each one of these, figure out this force would make the door rotate which direction around the hinge. For this one, if this is the door, the force is going that way, so if I push that direction, the door, you can see the door would rotate this way, counterclockwise, so that's the positive direction. The next one, if we look at this one here, if I try and push that direction, again, door is turning that way, that's the positive direction. What about the next one here? So if I pull that direction on the door, it's not turning at all, right? It's pulling the door that way, but it's not creating any torque. And the reason for that is the R is the distance from the pivot to the point where the force is acting. So R is here, F is there, and the angle between R and F, that's 180 degrees, and sine of 180 degrees is 0. So that's why. So that one actually is 0. Next one, if I push that way, it goes down, right? So it's rotating this way, that's clockwise, negative direction. And this one, negative. Now for magnitude. 6 forces, each of magnitude either F or 2F. So we'll have to figure that the long ones are 2F and the short ones are F. There we go. So F and 2F, rank them in order from largest to smallest, the 6 torques 1 to 6 about the hinge. So these are 1, 2, 3, 4, 5, and 6. I see one that has a torque of 0. Right, from this pivot, if I pull on the door that way, 0 torque. So that's going to be the smallest. So 6 is the smallest. How about the largest? We want the biggest possible force in the biggest possible distance, because torque is force times distance. So the largest possible distance is here, and the largest possible force is 2F. So this one is got to be the biggest one. That's number 2. All right, how about the rest? These are too hard to think about. Let's skip those until later. So this one is a single F at a distance of L over 2. This one is 2F at a distance L over 4. So if I compare F times L over 2, if I compare this, I get 2FL over 4, or FL over 2. This one is the same as that one. Now, what about these two, 3 and 5? Well, there's this one. Maybe if I can compare to this one. Remember the angle? So R is here, F is there. The angle for this one is 90 degrees. So sine is 1. So that's the biggest possible value of sine. I don't know what this angle is, but I know that the sine of whatever angle that is smaller than the sine of this one. So I know that the torque created by 5 has got to be smaller than the one by 4. So 5 is down there, And the sine of this angle is the same as the sine of that angle because those look the same. So those have to both be the same. So that one is number 3. So the largest is this one, then these two, and then these two, and then this is the last one.